Alright, welcome to week 3, part B, and get excited. This is one of my favorite lectures. It's really, really, really cool. Alright, let's get into it. So, we are going to continue talking about libraries and modules. Specifically today, we are going to talk about a module called the Turtle module. Really quick review. Library is a collection of code that you can use in your own code. Standard library is a library that is part of the programming language by default, so it's already downloaded when you download Python. And in Python, we organize these libraries into files, which we call modules. And today, we are going to talk about the Turtle module. So, the Turtle module is a graphics module in Python. And the way it works is you're going to imagine that you have a turtle at the center of your screen, and you can pretend your screen is like the XY coordinate plane. So your turtle starts at 0, 0, and you can give your turtle Python commands to move around, draw lines, draw shapes, do colors, a lot of really cool stuff. Alright, so this lecture is going to be very interactive, so I want you to make sure you follow along with me in idle. So go ahead, open up idle, make a new file. Here's the thing though, you cannot name it turtle.py. The reason being is because there's already a file named turtle.py. That is the turtle module. So just make sure you name your file something else. Turtle1 is fine. Turtle practice is fine. Just don't name it turtle.py. So go ahead and make a new file. Add the following line to the top of your file. Remember, this is the standard import line, but this time we are importing turtle, not math. And now, after you do that import turtle, you are going to make a turtle. So this is the idea of how you make a turtle. You give it a name. So for example, Amy. You can change Amy to whatever you want. It could be your name if you want. And then you do equals turtle.turtle. I know that seems kind of redundant, but this is how you make a new turtle. So please pay attention to the cases of the T's. So the first turtle is a lowercase t, second one is an uppercase T, and you do need those open close parentheses because this is a function call. This is making a turtle. So go ahead and add this to your file. And I'm going to go ahead and do it with you because this stuff is really fun. So I'm going to make a new file. So turtle practice, yay. Alright, then we'll have our import line, import turtle, and then Amy equals turtle.turtle. Awesome. Makes a new turtle. Let's go ahead and save it. And when you run this, you'll get a little turtle. So this right here, this arrow, I know it doesn't look like a turtle. There is a way you can make it look like a turtle, but for now we'll just look at the arrow. But this is our turtle. So this is Amy, because I named mine Amy. And now I can give Amy directions in code. So for example, I can tell Amy to move forward, or move backward, or turn right, or turn left. So let's go ahead and do that. So go ahead and go back to your file and go ahead and add these lines of code. Now, of course, if you named your turtle something other than Amy, you're going to have to use whatever name you chose for your turtle in front of these commands. But the idea is if you want the turtle to move forward, just say, hey, turtle, dot forward, and then inside you can give it some distance to move forward. Now these distances, they are in pixels, so I recommend using at least 20 so that you can see it. If you use something like 1 or 2, you're barely going to see it move because these are really, really tiny pixels. And then the units of measurement for turns, like right and left, that's in degrees, just standard degrees. So go ahead and have some fun with your turtle. Add a couple lines like that to your code. I'll do a couple as well. So Amy.forward 100. We'll go ahead and run it. And there goes your little turtle. So turtle went forward 100, and then it turned to the right by 40 degrees, then it went forward another 100. So if you want, you can go ahead and pause the video and have some more fun moving your turtle forward, right, left, or backward. Alright, couple more functions you can use in Turtle. So you can do name of your turtle dot go to x comma y. So forward and backward, those are all moving the turtle relative to wherever it currently is sitting on the screen. If you want it to go to a specific position, like an absolute position, remember this screen that comes up, let me run it again, the screen that comes up, this is the XY coordinate plane, and where it starts right here in the center, that's 0, 0. So for example, if you want it to go up here, you're going to give it, you know, positive x something, maybe 300, and then positive y 300. So this is positive x, positive y. This is negative x, positive y, and so on. It's the normal xy coordinate plane. So you can tell your turtle, hey, go to a specific xy position. You can also tell your turtle, hey, let's set your direction to a specific angle. So again, you can tell the turtle to turn right and left by 45 degrees, 90 degrees, whatever, but that will turn it relative to the direction it is currently facing. And you can tell the direction it's facing by the direction that the arrow is pointing. So again, the turtle, it comes up as an arrow. So the direction that arrow is pointing, that is the direction it's currently facing. That is the turtle's current heading, its current angle. So if you want to change it to an absolute angle, you can say set heading to some degrees, keeping in mind the fact that 0 degrees is when the turtle is facing directly to the right. So then you move counterclockwise from that. So if this is our XY coordinate plane right here, and your turtle comes up, by default it's pointing this direction, which is 0 degrees. This direction is going to be 90. This one's 180. And this one's 270. So those are the headings moving around. Alright, couple more cool things you can do with Turtle. So you want to imagine your turtle as it's moving around. It has a pen sort of attached to it, and if you tell the turtle to move forward, backward, whatever, or go to a specific coordinate, by default that pen is going to be uncapped. It's going to be pointing down on the paper. So if you tell it to move, it will draw a line. Now, if you want it to move without drawing a line, you can tell it, hey, pick your pen up. And the way you do that is you name a turtle dot pen up, and this will lift up the turtle pen. So for example, if you want to move the turtle to a specific location with go to, you can say, hey turtle, pick your pen up. Hey turtle, go to this XY coordinate, and then potentially draw more stuff there. So you pen up, go to, and then to put the turtle's pen back down, you can say pen down. So again, pen up picks the pen up, then you can move around without drawing any lines, and then when you're ready to draw stuff again, you go ahead and say, hey turtle, put your pen back down. And as you've seen already, by default the turtle's pen is down. So when you first pull up the turtle, its pen is down. It is going to draw as it moves around on the screen. Alright, so let's practice using the pen up and pen down. So go ahead and add this code to your file. So as you can see in this code, the turtle moves forward, you pick your pen up, you go to a specific location, and then you put the pen down, and then you keep drawing again. So go ahead and pause this video, add this code to your file, and run it, see what happens. Alright, so again, using pen up and pen down, that's how you're going to be able to move your turtle around without drawing any lines. So this is really useful if you want to draw on 2 different locations on your screen. Alright, couple more really cool functions you have with turtle. You can do name of your turtle dot circle, and then inside of the parentheses you give it one argument. This argument that you give it is going to be the radius of the circle. So this will make the turtle draw a circle with that radius. You can also have your turtle draw a dot. So this is just like a little teeny tiny dot. That could be useful if, I don't know, you want to make a connect the dots game or something like that. I don't know, you can get creative with it, but there's a lot of really cool turtle stuff you can do. Alright, so let's have some practice with this. So let's say I gave you this code. Let's say it's a test taking situation. I gave you this program. So I want you to determine on paper what your turtle is going to draw. So go ahead, pause the video and do that, and then when you're ready to sort of check and see if you drew the right thing, you can go ahead and check it by running the code. So again, draw this out on paper, pretend your pen is the turtle, draw it out, and then run the code to see what happens. Alright, so hopefully you did that. Let's move forward to another example. Alright, let's talk about this one. So same sort of idea. Let's do it on paper first. So draw this out on paper, and then you can run the code to see what happens. Now, I do want to point out one thing. There is a for loop here. And that's totally fine. You can use all the cool stuff that we've been talking about this entire class with this turtle stuff, which is actually super useful. So go ahead, pause the video, draw out on paper what's going to happen. Alright, so hopefully you see that Amy is going to draw a square here. So for each iteration of this for loop, the turtle, Amy, moves forward 100, and then she turns to the right by 90 degrees, which is basically that right angle, and then moves forward 100 again, turns, moves forward 100, does this 4 times, and draws a nice little square. Alright, so I want you to take a minute and change this code, and you can do it by typing it out. That's totally fine. You can do it directly into idle. Change this code so that instead of drawing a square, Amy's going to draw an equilateral triangle. And the hint that I'm going to give you is to draw an equilateral triangle, meaning a triangle that has all equal side lengths and side angles. So go ahead and draw it out on paper first, and pay really close attention to what your pen does. I'm going to bet you that the angle that you have to put in is going to be an angle that you maybe didn't expect. So go ahead and try to change this code in idle so that Amy draws an equilateral triangle. Pause the video and come back when you're ready. Alright, so hopefully you did this exercise and you saw that the angle to draw a triangle is 120 degrees. We'll talk about why that is in a second. And then of course, for your for loop, you're going to have 3 sides instead of 4, right? For a triangle instead of a square. So let's talk about why this angle is 120 and not 60. You might have thought it was going to be 60, but it's actually going to be 120. So let's talk about that. So let me go ahead and make a new file here. So let's just run through this code, right? Here's Amy. She pops up on the screen pointing this direction. So whenever I'm drawing turtle stuff on paper to sort of figure out what's going to happen, I always make sure to do just sort of like this dotted line just to sort of see what direction she is pointing in. And so, for example, if I told Amy to move forward by 100, Amy would be going in this direction. So let's go ahead, move Amy forward 100. As she moves, she draws that line. I'll go ahead and erase Amy here. So she drew this line as she moved forward 100, and then I'll go ahead and draw out these dotted lines again, just to show, okay, this is the direction Amy is currently pointing. So this is after Amy moves forward 100. Alright, so again, we want Amy to basically do this, right? So when she turns to the right, this is the angle that she's going to turn by. Now, to figure out what the degree of this angle is going to be, we have to do a little bit of geometry, alright? So the interior angle here for the equilateral triangle is 60 degrees, right? All these interior angles are going to be 60 degrees. That's just how it is in equilateral triangles. But we don't care about that angle. We don't care about the 60 degrees. We care about this angle right here that Amy is going to turn from the direction she's currently facing. So to figure out that angle, again, we have to do a little bit of geometry, right? We need to know that the angle of this line, this full line right here, that whole line is 180 degrees, right? So to get just this angle right here in the blue color, bluish purple color, we do 180 minus 60, which gives us 120 degrees. So that is where that 120 degrees angle comes from. So the takeaway from this example is when you are drawing shapes with turtle, be really careful with the degrees that you have your turtle turn. The angle that your turtle is going to turn, it's not necessarily this interior angle, but it's relative to the direction that it's already facing. So just make sure you pay close attention to that. If you have any questions about this example, please do let me know. Alright, that said, there is a lot of really cool stuff with the turtle module. So just like, with the math module where I just showed you like a couple of highlights, there are a lot more things that you can do with turtle. So I highly recommend checking out the Python docs, the Python documentation for turtle. So this is going to look kind of similar to the math documentation, except it will have turtle stuff. So a couple things you can do that are pretty fun is you can add color. You can make your turtle actually look like a turtle, and a lot more stuff. So you will actually have some practice during the lab in the programming assignment this week to look up the color functions in the turtle module. So you'll have some practice adding color to your code. If you do have any questions while looking at the color stuff and you want some help understanding what the documentation means, feel free to let me know, post the discussion forums, or send me an email. But otherwise, have fun with your turtles. I think this is a really cool point in the class. You can take everything that you've learned so far and use really cute little turtles to draw drawings with it. So I hope you have as much fun with it as I do.